A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. We have learned how electricity is being generated and distributed. As of now, electricity has reached our neighborhood electric poles. Let's see how we can bring electricity to our home. Different home appliances are working on the same house. So, it is essential to have a secure wiring inside the house for them to work safely. We usually see 4 lines in the poles, 3 of which are phase line and the one is neutral line. The phase line is also called the live line. We know that a potential difference is required for the current to flow. Here, the potential difference between the two phase lines is 400 volt. The potential difference between the phase line and the ground is 230 volt and the potential difference between the neutral line and the ground is 0. Haven't you noticed that so many lines pass through the electric poles, but we pull the wire from only 2 lines to our home? One of these is a phase line and the other is a neutral line. The potential difference between them is 230 volt. That is the difference between the phase line and the neutral line. So, we can say that the home receives electricity of 230 volts. But let me ask you a question. If someone touches a phase line while standing on the earth, will they be caught in a shock? Yes. But why is it so? Since the potential of the earth is assumed to be 0, the potential difference between the phase line and the earth will be 230 volt. If there is a potential difference, the current will flow. It adopts a path through his body that is less resistant to the current flowing from the phase line to the ground, and that's why he gets the shock. Have you noticed where the wires pulling from the pole to the house end up first? Yes, the first instrument is a watt-hour meter. What is the purpose of this one? The watt-hour meter is connected in the beginning in order to see how much electricity is being used. That is, a watt-hour meter is a device used to measure the total amount of electricity used in home. Power is measured in kilowatts. This one also known as unit. 1 unit of power is equal to 1 kilowatt hour. The industrial unit of electrical energy is kilowatt hour. A device with a power of 1000 watts consumes 1 unit power per hour. The following equation can be used to calculate the electricity used. Power in kilowatt hour is equal to power in watts into time in hour divided by 1000. After this, let's see how electricity flows into the house. From a watt-hour meter, electricity flows to the main fuse. This main fuse is connected in series with the phase line. The main fuse acts as a security system here. In case of excessive current due to a short circuit or overload, the fuse wire will melt and burst and the power supply to the circuit will be disconnected immediately. The circuit can be restored by replacing the fuse with the appropriate amperage after eliminating the chances for excess current in the circuit. After the main fuse, these wires are connected to the main switch. A lever can be seen on the main switch. You can turn the main switch on and off by pressing it up and down. This setting can be used to disconnect the power supply to the circuit in case of emergency, as the power supply to the next circuit will stop when the main switch is turned off. From the main switch, another line starts. The line is called earth line. The earth line is earthed with the metal part of the main switch. That is, the earth wire starts from the main switch. It then flows into the power supply network security systems MCB and ELCB. If you look at the wiring, you can see that the wires go from distribution board to various places in various branches. A phase line can be seen separately in each of these branch wirings. At the end of each of these branches, we attach different electrical appliances in parallel. As it is a parallel connection, each device can be controlled here with a separate switch. Do you recall the security systems we mentioned above? It was an MCB or miniature circuit breaker. Now, let us understand in detail what MCB is. MCB is a system used in branch circuits to replace fuses. When there is excessive current in the circuit due to short circuit or overload, the MCB switch automatically disconnects the circuit. After solving the problem in the circuit, you can turn on the MCB switch and restore the circuit. MCB works by using the thermal and magnetic effects of electricity. Let's see how this works. Whenever an excess current flows through the circuit, a strong magnetic field develops in it and around the solenoid in the MCB. At this point, the coil attracts and moves the soft piece of iron. The spring action strikes the piece of metal and breaks the circuit. Thus, MCB protects electrical circuits. ELCB is another device that works similarly. ELCB allows the circuit to be disconnected automatically in the event of a current leak in the circuit due to insulation failure or otherwise. As a result, those who come in contact with the electrical circuit or equipment do not get a shock. The RCCB or residual current circuit breaker is now being used instead of ELCB to ensure greater safety. All we knew about household electrification was the wire coming into the house and the equipments that worked with it. But now we know how the current reaches the devices and what are the functions of such devices.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ ENCLAPS the Learning App.